I'll be showing you how to use the ShakableTransform and ShakableRigidbody components, and their 2D counterparts behave exactly the same. I'm going to first start by showing you the ShakableRigidbody. So I need a 3D object in my scene to use that, as I'm going to use the 3D variant. I'm just going to go to Game Object, 3D Object, and Cube. It already has my box collider and mesh renderer. Since I'm going to use the ShakableRigidbody, I'm going to attach a rigid body component to it. I just want to make sure this is working fine, so I'm going to hit play. It should fall to the ground. Perfect. And now I'm going to set up the ShakableRigidbody script. Now I'm going to add ShakableRigidbody. And one thing I want to point out real quick is that the ShakableRigidbody and ShakableTransform have the exact same option. So I'm going to describe the options in the ShakableRigidbody, and just know that they transfer over to the ShakableTransform as well. And if I were to remove this and show you the ShakableRigidbody 2D, you'll see that that has the same options as well. Just as well, the ShakableTransform 2D. Okay, so let's get to configuring and talking about the ShakableRigidbody. The first option you have is which shaker type to use. By default, it will be camera shaker, and secondary, you have object shaker. Choose camera shaker if you wish to have this object respond to camera shake, and choose object shaker if you have an object shaker script attached and you want to only shake this individual object. Next, you have the position and rotation multipliers. This is the scale of which to apply forces to the rigid body as they are applied to the camera as influence. Lower values would mean that the rigid body would shake less than the camera, whereas higher values mean that it would shake more. And the same applies to transforms. Instead of forces, it would just rotate or move the transform more or less. Beyond that, we have require in view. When ticked, this object will only shake when it is in view of a camera. If there is no renderer on this object, which in this case there is a mesh renderer, then a sprite renderer with no image will be added. This is so that we can get a callback for when the renderer comes in view. The next option, include children, will also shake any rigid body children beneath the cube object. This is useful because if you have a lot of rigid bodies that are grouped together which you want to shake, you can have one shakable rigid body control all of them. And just to show you real quick what that might look like, I'm going to create an empty object. I'm just going to call it cubes. And I'm going to attach my ShakableRigidbody script to it. And then I would drag my cube underneath. And in this instance, if I'm going to include children on my cube's parent transform, that I don't need a ShakableRigidbody on the cubes beneath it, in which I would then remove component, but keep in the rigid body, of course, because I still want it to shake rigid bodies, and then I would just duplicate the cubes and then move them around as I see fit. Then when a shake occurs, this single ShakableRigidbody will receive the call, and since include children is ticked, it will then begin shaking all the children rigid bodies beneath it. I'm going to just revert things back real quick though, just the way we had it to keep things simple. Next, I have ignore self. This option will only be visible when including children in a future update. If checked, the parent object will be ignored from shakes. You probably won't be using this much on a ShakableRigidbody. There is a good chance, however, when you are shaking transforms, you might group them all together and you don't want to shake the parent transform, and that's when this would come in handy. Beyond that, you have include and active. This will also only be available if include children is ticked. This will include inactive objects when searching for objects to shake. This is useful if you have objects you want to shake at a later point but are currently inactive in your scene. Next, you have localized shake. This will transform the influences of the shake to the rigid body. For example, if you had a box that was turned slightly right and you had a positional shake that moved on the z-axis, which is generally forward, this would move relatively forward and back to the box's current rotation. This is another feature that is probably better suited for transforms, but you always have the option to apply them to rigid bodies as well. Lastly, you have randomized directions. This will randomly flip the direction of the shake at runtime as well at the beginning. This is useful, so if you have a lot of cubes together, in my demo for example, that they won't all shake the same direction. And at times, the direction will even change in the middle of the shake. This works really well with rigid bodies. And if you're using a ShakableTransform, then the direction will only change at the beginning of the shake. Now that you know how everything works, let's go ahead and try it out. Alright, so we have our cube with the rigid body attached and the ShakableRigidbody script. I'm going to go ahead and run my off-road shake. You can see already that's wobbling a bit, so if I crank this up a little bit more, you're going to notice that's going to be affected. And if I multiply the rotation, you're going to notice it will go a bit crazy. So you probably won't do this, but for the sake of science, you can see now that it is going absolutely nuts, indicating that it is working. Now that you have an understanding of how to use each feature, I'm going to show you how quickly you can do this from scratch. I'm just going to go to 3D, Cube, add a rigid body, and add a shakable rigid body. And that's it. Now I'm going to move it into position, hit play, and then I will run my shake, and you can see that it will react accordingly.